Hey guys, welcome to lesson 23A, make line plots and interpret data. So this is a line plot right here on the screen. So a line plot is used to show information. So the name of this line plot is tomato weight in pounds. So this says 0 pounds, and no tomatoes weigh 0 pounds, right? And then there are 1, 2, 3, 4 tomatoes that weigh 1/8 of a pound, 3 tomatoes that weigh 1/4 of a pound, 2 that weigh 3/8, 3 that weigh a half, and 1 that weighs 5/8. Obviously 0 for 3/4, and 1 that weighs 7/8. So we use that information to answer the questions below. So the greatest number of tomatoes, well, which one of those has the most X's? And if you look, they really try to keep those X's the same size so you can kind of glance quickly. And you can see that 1/8 pound is the right answer. So I have to pull that screen sketch up again. My apologies. So this is 1/8, and pound is abbreviated that way. Which best describes how the weights are spread out? So look at those X's. Are they all clustered in a small area, or are they spread out? So we kind of look clustered between 0 and a half a pound. So here is between a 0 and a half a pound, and goodness gracious, almost every tomato is in that. So that looks like a good possibility. Clustered between a half pound and 1 pound, a half pound and 1 pound is here. A cluster is grouped together. That is really not a big cluster there, so definitely not that one. Or spread out between 0 and 1. Well, I think when I look at what I circled, that they are clustered between 0 and a half pound. Hopefully that makes sense to you. Are the tomatoes on the heavier or lighter end of the scale? So I want you to know that they did organize these from the least to the greatest. So this is in order. So obviously 0 pounds weighs the least. So if we look at this, most of them are between 0 and a half. So that would be on the lighter side. Okay. There's only these tomatoes that are towards the heavier side. Are there any tomatoes whose weight is very different from the rest? Yeah, there's one that's really far off the rest. Do you guys see it? Let me erase my screen for you. This one is kind of all by itself. The rest are all within this group except for that one. So when it says, is there any weight that's different from the rest? You would say yes, 7/8 pound. By the way, LB is how you show pound. And then finally, E and F, what is the difference between the weights of the heaviest tomato and how many times the weight is the lightest tomato to the heaviest tomato? So difference, that's the key word here. And again, I'm going to have to pull up my screen sketch here. So the key word here is difference. That means we subtract. So the lightest tomato is 1/8, and the heaviest is 7/8. So 7/8 is a bigger number. So 7/8 is heaviest minus the lightest at 1/8. Oh, our denominators are the same, so that's nice. So the difference is 6/8 of a pound. And then F is kind of hard. Okay, it says how many times the weight of the lightest tomato is the heaviest tomato. And so the lightest tomato is 1/8 and the heaviest is 7/8. So that is 7 times heavier, because what times 1/8 would you get? 7/8, and so from 1 to 7 is 7 times heavier, or we could just write 7 times. All right, so that's the first page. So now we are going to scroll to the next page. It says find out more. Plotting data on a line helps you get a picture of what the data looks like and how the data are spread out. Each X represents one piece of data. So the taller stacks of X's means more data. So again, if you look at this right here, it shows us the same line plot we used on the page before. It says in the red right there, it says most of the data are clustered between 1/8 and 1/2. You can use operation with data values to come up with ways to describe the data. First of all, they said you can subtract 7/8 minus 1/8 to find the difference between the heaviest and the lightest tomato. That shows you how much the weights vary. So 6/8 is how much they vary. Divide 7/8 divided by 1/8 to find that the heaviest tomato is 7 times heavier than the lightest tomato. That also gives us a comparison between the least and the greatest data value. So right here it says reflect. Suppose you have one more tomato with a weight of 3/4 pounds. Would that change how much the weights vary? Explain. So if we were to put an X at 3/4 here, right there, it honestly would not change the weight because it's not 3/4 is not the heaviest and it's not the lightest. So the variation will not change. The difference will stay the same between the lightest and the heaviest. So you just need to put no because it's not the heaviest or the lightest tomato. So that is it for the first 2 pages. Hopefully that makes some sense. Thank you.